Object communication has always been the soul of gameplay. For example, a surveillance camera looking at the player once the player is detected, a character opening a door by walking into a volume, or a laser checking for a specific object to trigger any functionality in the game. In Unity, to achieve this level of communication or higher, you must hard-code it or buy expensive tool. But do not worry, I have built a set of sensors that I'm using in these examples and they will help you out. Check them out. The first one is called trigger sensor, which registers those objects that enter a volume and remove them from the registration once they leave. For this to work, we first need to assign the layer that we want to interact with. Once done, we can move an object of the same layer inside the volume, and as you see, it gets registered. Now we can move it outside the volume, and as you see, it gets removed from the list or registration. We can try doing the same with two objects now. We move them both inside the volume, and both of them get registered. Now we move them both outside the volume, and both of them get removed. Now, if you want to specify more, you can also set a tag and only interact with those objects that has a tag of the same type. In the object to ignore setting, you can add those instances ID of those objects that you want to ignore by default. If you want to know how to get the instance ID of a game object, I'm gonna leave you a link to the Unity documentation right in the description. The sensor can call two events. The onRegister event, which is triggered once an object is registered to the sensor, and the onLeave event, which is triggered once an object is removed from the sensor. The area sensor is checking for every X number of seconds that can be set on the test frequency for those objects that are inside a radius. If they ever get outside the radius, they get removed from the registration. You can also specify a field of view, meaning that those objects outside the field of view, they will be ignored. If you wanna get even cooler, you can set an obstacle layer, and this obstacle layer will help the sensor filter those objects that are being blocked by obstacles, meaning that those objects that are being blocked will be ignored by the sensor. But what if we simply want the functionality of a laser sensor like in the intro? Guess what? I have it for you. It is called the cast sensor, which for now can only register one object at a time. Let's make it register multiple objects by clicking on the multiple target checkbox. Now the sensor has registered all three of them, and if we move the sensor away, they get removed from the list. You can also get fancy here with obstacle. Let's first add an obstacle layer, and as I move the obstacle around, the sensor will ignore those objects that are being blocked by the obstacle. Now, I wanna tell you this. Don't even bother trying to make a 2D version of all this. I already made them for you. Now, let me know in the comments if you want me to showcase any of the mechanics that I've shown in the intro, or any other mechanic that you need help with. If you like this tool and you wanna get it, please like and subscribe. That will show me your gratitude. And you can get it on my Discord server. The link is in the description below. See you next week.